In 1942, Ferdinand Porsche stood before Adolf Hitler and promised a mechanical miracle that defied the fundamental laws of physics. By 1945, Porsche and his team of arrogant engineers had incinerated millions of Reichsmarks and hoarded thousands of tons of critical alloy steel to forge a 188-ton stationary tomb. They called it the Panzerkampfwagen VIII Maus, but this was no mouse. It was a 10-meter-long, 3.6-meter-wide steel leviathan that cannibalized the German war machine from the inside out. While the Eastern Front bled dry of basic resources, Krupp metallurgists were ordered to drain the Third Reich's remaining reserves of chromium and molybdenum, just to cast the impregnable hull of the Porsche Typ 205. The sheer scale of this engineering hubris began at the very top with a massive 55-ton turret that weighed more than an entire fully combat-loaded Tiger I tank. Inside this claustrophobic steel dome, the engineers crammed a monstrous 128mm KWK 44L/55 main gun alongside a Sabotage 75mm KWK 44L/36 coaxial cannon. Firing the 128mm gun generated an apocalyptic recoil force of up to 80 tons. To manage this kinetic violence, Porsche's team engineered massive high-drop pneumatic recoil cylinders, but the sheer shockwave of a single test shot threatened to shear the 3-meter-wide turret ring straight off its chassis. For a layman to understand this kinetic energy, imagine detonating a commercial demolition charge inside a closed bank vault, where the recoil slams backward with the force of a speeding locomotive crashing into a concrete barrier. The loaders were trapped inside a deafening pressure cooker, forced to manually heave 28-kilogram two-part ammunition shells into the breach, while the turret's internal temperature spiked dangerously close to 45 degrees Celsius. The defensive philosophy of the Maus was a testament to metallurgical madness. The Krupp foundries poured a frontal glacis plate that was 240 millimeters thick, angled at a steep 55 degrees, to maximize line-of-sight thickness to over 350 millimeters of solid steel. The side armor measured an astonishing 180 millimeters, while the rear was plated with 150 millimeters of hardened alloy. Deflecting a 122 millimeter Soviet armor-piercing shell against this 240 millimeter glacis would generate thermal friction temperatures exceeding 1,500 degrees Celsius, instantly melting the incoming projectile into a harmless splatter of molten slag. It was an impenetrable fortress absorbing kinetic impacts equivalent to a meteorite strike. However, forging these monolithic steel slabs required specialized casting pits that consumed weeks of continuous high-temperature smelting, paralyzing other critical manufacturing lines across the Ruhr Valley. Moving this 188-ton block of dead weight out of the Alket assembly plant in Berlin triggered an immediate structural catastrophe. The Porsche suspension system utilized volute spring bogies with 24 massive road wheels per side, all rolling on, incredibly wide 1.1-meter track links. Each track link was cast from heavy manganese steel, and the entire continuous track assembly weighed over 12 tons per side. The ground pressure exerted by the tracks reached an earth-crushing 1.45 kilograms per square centimeter. Before the prototype even reached the battlefield, the sheer static load of the Maus cracked the Alket factory's reinforced concrete floor. Let us dissect the track mechanics further. To keep this 188-ton behemoth from sinking directly to the Earth's mantle, the tracks had to be excessively wide, severely restricting the internal hull width. The space between the massive track assemblies became a suffocating corridor, leaving barely enough room for the central drive mechanisms. Engineers had to design an interlocking cast steel track system, where each link was connected by friction-fit pins. During a standard 0-degree pivot, turn the outer edge of the 1.1-meter track, dragged against the compacted soil, creating an opposing frictional force of hundreds of thousands of newtons. The Torsion bars snapped under the asymmetrical load, twisting the suspension arms until the high carbon steel structurally failed with a deafening metallic screech. Replacing a single broken track link in the field required a specialized gantry crane and a crew of 10 men working continuously for 8 hours, exposed completely to enemy fire. The Krupp metallurgists faced another catastrophic failure point in the turret traverse mechanism. Rotating a 55-ton asymmetrical steel block required an electric traverse motor capable of generating thousands of newton-meters of torque. When the tank was parked on a slight incline of merely 10 degrees gravity, pulled the 128-millimeter gun barrel downward. The traverse motor had to fight against the entire 55-ton weight of the turret just to rotate the gun uphill. The copper coils inside the traverse motor would overheat within minutes, melting the electrical insulation and filling the crew compartment with toxic acrid electrical smoke. The gunners were blinded and choking on vaporized copper and burning rubber, completely neutralizing the tank's offensive capability before a single enemy target was acquired. Ferdinand Porsche had effectively engineered a super-heavy bunker that demanded an impossible equilibrium of forces. The 240-millimeter frontal armor successfully neutralized external threats, but the sheer mass of that protection turned the internal physics into a relentless enemy. Every single gear, sprocket, and bearing was subjected to continuous yield stress. The structural integrity of the drive sprockets degraded with every single revolution, the hardened steel teeth grinding themselves down into useless metal shavings against the sheer, unyielding weight of the tracks. Porsche's design team had constructed an unstoppable shield, but they fundamentally failed to understand that extreme armor is not a weapon. It is a physical death sentence dictated by gravity. The 240-millimeter steel hull was a thermodynamic trap. The real nightmare was not the enemy artillery raining down from the sky. The true horror lurked beneath the 50-millimeter armored floor of the crew compartment, where a highly volatile Petrol-Electric hybrid powertrain sat waiting to detonate under the unbearable strain of moving a 188-ton mountain. Beneath the heavy armored decking of the Maus laid an engineering concept so overly complicated that it doomed the entire project, the Petrol-Electric hybrid transmission. To move 188 tons of solid steel, Ferdinand Porsche repurposed a massive Daimler-Benz MB 509 V12 aircraft engine capable of generating 1,080 horsepower. However, in a catastrophic display of mechanical over-engineering, this colossal V12 did not connect to a traditional mechanical gearbox. Instead, it was bolted directly to a gargantuan Siemens-Schuckert electrical generator weighing over 3 tons. The internal combustion engine screamed at a maximum of 2,500 revolutions per minute, purely to spin the generator's armature, which then fed high-voltage electrical current of up to 800 amps through a complex web of thick copper cables to 2 independent electric motors driving the rear track sprockets. For the crew trapped inside the engine compartment was a thermodynamic hellscape. The V12 engine consumed air and expelled toxic exhaust at a terrifying rate, elevating the internal ambient temperature of the hull to a blistering 50 degrees Celsius. Imagine being locked inside a steel shipping container left in the Sahara sun, while a commercial jet engine idles right next to your ears. The noise was physically agonizing, vibrating through the bone marrow of the engineers while the intense heat threatened to melt the electrical insulation off the high-voltage cables. If a single pressurized coolant line ruptured, the resulting superheated steam explosion would have instantly boiled the crew alive within their 240mm steel cage. When the V1 prototype finally rolled out for testing at the Böblingen, proving grounds, the theoretical mathematics clashed violently with real-world terrestrial physics. The electrical transmission was incredibly inefficient. To force the 188-ton Maus to a top speed of just 13 kilometers per hour, the Daimler-Benz engine had to run at its absolute thermal limit. The torque requirements to overcome the dead weight of the tracks reached an excess of 15,000 Newton-meters. The massive final drive gears, attempting to translate electrical energy into physical momentum, were subjected to shear stresses that caused the cast steel gear teeth to splinter like brittle glass. In one instance, the violent counter-rotational forces sheared the hardened steel crankshaft entirely in half right on the test stand. The logistical reality of fueling this monster was an even darker comedy. The Maus consumed an apocalyptic 3,800 liters of high-octane aviation fuel for every 100 kilometers traveled. To put this catastrophic inefficiency into perspective, an average modern family sedan could drive around the entire circumference of the Earth on the same amount of fuel the Maus required, just to travel the distance of a morning commute. The tank had to be followed by an entire fleet of vulnerable fuel trucks, turning the supposedly invincible super heavy tank into a massive immobile target the moment its umbilical cord to the supply lines was severed. Furthermore, the 1.45 kilograms per square centimeter of ground pressure transformed the Earth itself into the Maus's greatest enemy. During field trials, the moment the 188-ton beast rolled off paved concrete and onto soft soil, it began to bury itself. The tracks dug deep into the mud, and the extreme weight caused the hull to sink at a rate of 5 centimeters per minute. If the Maus stopped moving in a swampy field, it immediately became a permanent geological feature. The original design even included a ludicrous snorkel system, allowing 2 Maus tanks to connect via a submarine electric cable to cross rivers because absolutely no bridge in Europe could support their weight. This meant relying on a heavily stressed 800-amp electrical grid submerged entirely underwater, a perfect recipe for short circuits and the electrocution of the crew. The final pathetic climax of the Porsche Typ 205 unfolded not in a blaze of combat glory, but in an act of desperate sabotage. By April 1945, the Soviet 61st Guards Tank Brigade was rapidly advancing towards the Kummersdorf proving grounds where the fully armed V2 prototype was stranded. With no fuel to move, no bridge to cross, and the transmission critically failing, the German engineers realized their 188-ton mechanical god was nothing more than a giant helpless paperweight. Fearing the Soviet intelligence units would capture the intact technology, the Krupp and Porsche technicians packed the interior of the V2 prototype with high-yield demolition charges. The subsequent detonation was a display of internal explosive physics that destroyed millions of Reichsmarks in a single millisecond. The blast wave expanded rapidly inside the sealed steel hull, finding the only path of least resistance, the turret ring. The extreme explosive pressure violently sheared the massive locking bolts and literally lifted the entire 55-ton turret into the air, tossing it several meters away from the shattered chassis. When the Red Army finally arrived, they did not find an unstoppable wonder weapon. They found a fractured burning metallic carcass, a monument to the delusion of a collapsing empire. The Panzerkampfwagen VIII Maus never fired a single 128mm shell in anger. It never crushed an enemy tank beneath its 1.1-meter wide tracks. It was defeated entirely by its own mass, destroyed by the undeniable laws of thermodynamics and gravity. It stands in history not as a triumph of mechanical engineering, but as the ultimate fatal flaw of an ideology obsessed with impossible scale. If you found yourself staring at these blueprints, would you have the courage to tell a dictator that his 200-ton dream was physically impossible, or would you blindly build the coffin? Make sure to hit that subscribe button, leave a comment down below with your thoughts on this mechanical monstrosity, and stay tuned to DEFUNCT for our next deep dive into the forgotten failures of military history. Don't let the algorithms bury us like the mouse in the mud. Engage with the video, and I will see you in the next breakdown.